All right. Sorry, folks. I'm turn off the. Gotta turn off the AC in here. It's too cold now. It was too warm. I got the opposite problem. Um, but we are back, and I just finished editing and indexing sort of all my videos on these Sega CDs, which is cool because, my God, they were a mess. And I'm sure it wouldn't be useful for anybody to learn from them. Uh, but we have come full circle. So um, I'm back now. This is part four, maybe part five. I don't know, but it's enough parts on this water damaged Sega CD. So this Sega CD is just such a mess. Um, and so, oh hey, you get to catch me on the dark side. Oh. Um, all right, let me just see where we're at. Yeah, so yeah, somebody popped in there. Oh, you're moderating. Oh, thank you. Um, all right, so yeah, let me kill the. Where's the AC control? Oh my God. I just got AC installed in here, which is great because the garage can get quite warm in California. Um, so oh yeah, I mean, I don't know what we're gonna be able to do with this one, frankly. Like this is it's a water damaged Sega CD, right? So we've been at it before, right? We've been at it before, and I mean, I don't know what we're going to get out of it, but we'll give it a blast. And in order, I mean, look, I think step one. Sorry, I'm just walking back and forward here. I think step one here is now that I've indexed my videos, I know where I know what the values are that I need to read from this from the different um I have a video where I check the reference voltages, and now I've indexed that video so like I know I can go back and check it now. I've got like 15 videos on this Sega CD now. So I get I get a few views on the live videos. I just don't know if they get promoted or if they show up in search the same way as if you actually make an actual repair video with like a real thumbnail or whatever. Um, so it really kind of depends. Um, I mean, like I'm not really bothered about the views, but I am curious if like this kind of low effort content, which to be fair, it is probably low effort, but I don't have a lot of time to do this stuff, so that's about kind of where it's at. But does it get promoted or not? I don't know. Okay, so I said bad Q302 is what I wrote here from the last video, and then just put moisture, which we did clean this thing, and we did install a new transistor. So yeah, so that was that. Um, all right, let me just go back for 1 second. Door leaf spring. What was the? Oh my God. Door leaf spring. Still, my most popular videos, just looking there, are these ones about the Bose SoundTouch 300, which must be breaking all over the country because it does seem that everybody has that problem. Um, Reference voltages. Here it is. So this video, I'll take away the. Also, I don't know if this is because of my new camera, but I don't know if my videos are 4K anymore, or do you even have a 4K option? All right, let me go here. There's my paste bin. All right, so there's my paste bin. Q301, base 0 volt, emitter collector 1111. Yeah. Yeah, I'm just looking at my paste bin here. Yeah, 7805, 11.38 volts in. Q302 on a working unit, it has 0.731 at the base. All right, I'll just keep these over here. That paste bin is long gone. Uh, so it looks like I didn't save it or something. So, all right. Okay, so yeah, so let's plug this in to Genesis. This might be a short stream. Kind of tired. But let's just see what we can do. This uses the JVC drive, I believe. It's the JVC drive unit. So if we and I don't well, I guess I do have a partially working one of those. And I did order some drives, the little motors. All the motors are the exact same motor for all of these, it turns out, which is great. Let me just put this keyboard back here. Put it on the car. Um, all right, so we're gonna have to go. Okay. All right, there you go. And then this goes in here, or does it? One of these, they're kind of both identical, but they're not identical. That must go in there. Yeah, it does. And then this must go in here. All right, that's cool. Interesting thing was we were looking at that circuit last night on the LED, and there's a we're looking at the circuit on the LED last night, and we had the little transistor going into it. So there might be a case of that happening on this unit too. Now let's just see. Yeah, nothing. So we should get bias. All right, so let's bring in the scope and test some voltages. So we should get 11 volts, or some sort of reasonable voltage coming in on collectors and emitters, and 0 on the base, and the collector should send to the voltage regulator, and blah blah blah. So let's just see where this is going bad. And I'll switch over to the scope. Is this unit 1? This is unit 1. This is the water damaged unit. So we might have to go like similarly like we did with the one where we found the solder that fell off. We might need to go over this board, like just the entire board on the scope. Well, before we do that, let's have a look at the main culprit area for these units, which is right here. So this is currently on. Or should be currently on, is it? Maybe it's not on. Oh, it's on now. Okay, so let's get meter. All right, so I have the meter here, and I'll put the meter down on the desk so that you can see. And I don't think I need the sharp ones. All right, so I'm going to probe. I'm going to put just on the ground of the DC in, and then we're going to check. This should be the base. It should be 0 volts. Oh, sorry. Should be 0 volts. Yep. Well, I mean, close enough. Yeah, 11. Okay, so that's good. I think this is base 0.7. Emitter. Oh yeah, that's base emitter. 003 collector. 0013. Okay, let me just check my paste bin, or not my paste bin, but like the video. I have to full screen my video. Q3 010 emitter, 020 collector. Okay, 010 emitter, 020 collector. 010 emitter. Whoops, sorry. That is interesting. So that's a lot less. And 020 collector. 0.013. That's almost dead. So Q302 is, don't know if it's bad, but it's just not matching the reference voltages that I had from the working unit. The base is 0731 on the working unit, and the base here, whoops, the base here is 0735. So like I'm kind of sort of feeling like it might be okay. Let's test the voltage regulator. The voltage regulator. Whoa. I think that's 5 volts out. This is ground. This must be in. 1159. What's SVCC? 1160. Yeah. So the voltage regulator is 5 triple zeros out. I mean, that's insane. That's amazing, right? So, oh, sorry. Give me one sec. So it's good. It's good. It's good. It's good news, right? So that mean, why does that say plus 7V? Does that mean that that test point's plus 7 volts? Is that what it's supposed to be? Let me just test that test point. That's 1162. So, S ground. Yeah. Okay. That's ground 1, ground 5, blah, 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 blah. Okay. So we will have to go back around and, whoa, sorry. We'll have to go back around to see what this, let me just go back again. Yeah, so there's nothing scope. Let me just go back to scope again. Okay. So we have good voltages on that. Well, we also know fuse is good. TPA. I don't know what TPA is. I want to just probe TPA just to see what the voltage is on that, and then we can see what it is on the schematic. 1177. Okay, what about you? What about the other side of this resistor? Nothing. This resistor, 0.7. 013. 778. Okay. Okay, so I'm gonna turn off the power for a second. I have to look at the schematic. So we have 5 volts. We have 5 volts to the regulator, which is so whatever's supposed to be powered by that 12 volts should be getting it. right? So let's find out what's supposed to be powered by that 5 volts. And then let's see, maybe there could be a bunch of IC chips that are dead. And then if this is if the ICs are if there's a problem with the ICs, then this board just becomes a parts board, which isn't the worst, right? Because you know, it's not the worst because I actually don't have a parts board. So that's why it's not the worst. So but so much so much moisture damage on this thing that it's just insane. So like I'm not hopeful about this one. Plus 5 volts. Interesting. Like why would you have I just want to see it I want to see if that test point is actually plus 5 volts. Hmm. Yes it is. Exactly. 5000. All right. This is I mean that's good too. All right, schematic time. Schematic time. Okay. Air fryer? Oh, sorry. What were you saying about air fryer? What should I use that for? You saying bake the board? Do you think? Yeah, maybe I lost you. Do you mean baking the board could help with just kind of re reflowing everything? You might not be wrong. Um, okay, so definitely gonna have to go. Let's go back to Firefox. Let's get out the schematic for the Model 2. I'm using the schematic that you generally have been sending me. Dehydrating the PCB, yeah, yeah. I mean, if it's not dry by now, it's never going to be. All right, so let's get out of here. So here's our power circuit, right? Here's our power circuit. IC301 is the voltage regulator, right? Q30 Q Q302, which is down here, the collector is outbound to V out as well, right? So the collector Q301 goes to Q302, and then Q302 is actually kind of tagged in to or overlaps with V out as well. So V out of this regulator, I mean, it powers a few different rails, right? So there's VCC3, VCC2, and AVCC, right? Um, there's VCC3, which comes in here, test point 128 VCC, right? Um, VCC2 is over here in AVCC, like they're all sort of tagged off. So there's a few rails off of this, right? But I think yeah, so VCC2 is into IC114, right? So so let's just think about this for a second, right? Like what's I mean the CP, the unit's unlikely to boot, right? If one of the most important ICs is dead, and I mean the CPU is probably where we should start. What do you think? Like, there's obviously some Sega custom chips here, but like this thing's not going to boot without the CPU. So I think we're going to have to probe the CPU for um, let's probe the CPU and let's see what's going on with it. Um, let's see. We can also not only can we probe the CPU, we can also put some stuff on the data lines if we want to, if it is actually alive. Um, but now, although, wait a second. let me just take off the. I'm just going to take off the thing. This may be a case of now we're getting into sort of I need to power this board with a bench supply because I'm not going to be able to probe anything with the Genesis on there, you know. So so that's just something I wasn't really. Where did I put my bench supply actually? Oh, it's a red. I think it's actually over there on the other. It's on the other desk, I think. All right, it doesn't matter. Anyway, just there's ways to boot these things up without the Genesis attached. So, yeah. So give me a second here now. All right. So what do we do? Clock VPA VC, which VC. There's VCC 14 and 52. VCC 2. Data lines, stress lines, clock VPA. We can check the clock. We can see if the oscillator could, these are all the same kind of things that go wrong with these units, right? Pin 15 is the clock. Um, looks like 14 and 52. They're all, there's a lot of stuff. So we can start at the CPU and we can work our way back. Um, was that? Genesis basically video output. Yeah. So let's just move to overhead for a second and just take a look. Okay. Now we might zoom in on this board now because let me see now. Let me just change that. That looks relatively. All right, that looks relatively in focus. So I think that should do. All right, moisture. Yeah, so there's our CPU. Okay, right here. So I think we need to probe this guy. We will need to get the data sheet. Because I guess it does say 61. Sorry. Let me just get the Genesis out of here for a second. And I'm pretty correct. Am I correct? Yeah. When the Genesis is on, we're not going to probe anything. So we do have to do the job of powering this board without the Genesis, which shouldn't be too bad. But okay, so actually not. You know what? I probably won't need the schematic or the data sheet because it does number out the pins. So um so I do wonder now. Yeah, sorry, let me switch the scope for a second. Yeah, so there we go. There is the Motorola. All right, and then what do we got? There's pin 1, there's pin 26, yada yada yada. Okay, so I think it was pin 14. Oh, sorry, 10 to 26. Sorry, not 27 to. Okay, so where's pin 1 then? Oh, there's 6. Now I'm just confused. Where's pin 1? Yeah, so there's 44. There's 43. to 27, and there's one. Yeah, it should be 1 to 26, not 10 to 26. I don't know why it says 10 there. That is 1 to 26, I would guess. Um, yeah, anyway, we'll let's go get that data sheet. So just so we have it in that. So because this will be a particular sort of flavor of that chip. Oh my God. Okay, so oh look, that's where I tried to copy and paste something you sent me, and it put in some Twitch stuff. All right, so what's this? MC. Oh, that didn't work. MC 68 H C 000 FN 12 data sheet. Well, I mean, there you go. There's all data sheet. Although I hate the way all. Oh no. Uh, literal specifications. Yeah, okay. So this is kind of not what I'm looking for. I need the chip data sheet. That this looks like it's a reference manual for the. Oh, no. That's not what I want. I don't think that's what I want. Yeah, let me see. Maybe it is what I want. It just doesn't. Ninth edition. I want that chip though. Maybe it's I need. It could be that I need the 4C71T or something on it. I don't know. This is just. Yeah, back when they used to do before phones, right? Data sheet 4C71T. Now that could be just be a batch code. Show results with no. Okay, QQYG9, QQYG9 334. Now that does sound like some sort of a. All right, so no, it's not. So it looks like actually if I say pin out, maybe that would be better. So if F1, FNL12, HC11F1, when's HCFN12? I mean, I'm going to guess that these are all very similar though, but at the same time, sorry, let's open this up. Oh, I see. Oh, it's a different. It's just the megahertz. Sega Mega CD2. Okay. All right. Well. All right. So what I really need is pinout. So that's what's important. Um, yeah. So maybe the data sheet. Maybe the data sheet was there. Let me just go back to like all. Um, yeah. Sorry. Blah blah blah. Oh, okay. I wonder if maybe it was a custom Motorola chip that was shipped to um that was shipped to Sega and SNK. Um, oh, interesting. Well, does pin one really begin in the middle of the? Is that what they're trying to say? That pin one begins in the middle of the thing here. That's why it said 10 to 20. Yeah, 10 to 26, right? This kind of does line up, but like if you look here, it says one is there. Just open that image in new tab. Okay, let me just control plus that. Right. So what is it? There's pin one. And it said pin. See, this is where it gets weird though. This said pin 14. They said pin 14 and pin 52. Um, sorry, let me just go back to the Mega CD for a second, right? See here, it said VCC. It fit 14. 14 looks like VCC and 52. Then you go back to this pin out. 14 is a data line, and 52 is a what? 52 is an address line. So yeah, so maybe not exactly. But it doesn't matter too much, I think, because we I don't have the exact pin out here, but um I think we can figure this out. Oh, 68,000 Tech Wiki. Console 5 Tech Wiki. Oh, look at that. 14 VCC, 52 address. Yeah, so I don't know what's going on there. So it's always the same, it looks like. Because they're just going like 68,000 and then this is just always the same address line. Um, 14 is VCC, clock is okay. Let me just switch back to scope for a sec. Oh no, I am on scope. Oh, that whole time you guys didn't know what I was doing. All right, okay, sorry. Um, there, yeah, there it is. Look, there's pin one. So, all right. So pin 14 is VCC. Well, that should be pretty easy to determine. All right, let me just go and take a quick look. We will actually use the Retro 6 wiki. Okay. Sega CD powering it on by itself. Power circuit. I think here the 9-volt input from the power plug you put in Mega CD Sega sees the power coming in. The power flows through the choke and the fuse. Blah blah blah. There's something down here about how to power this thing by bypassing console power on. I just want to test power and power circuit. Is it as simple? Hello. How's it going, graphics? Um, if you do not have a Mega Drive Genesis, as simple as enabling the PMP trip by applying 9-volt to the base of Q302, or bypass those transistors altogether and just apply 9-volt to the input of the 5-volt LDO regulator, IC6. Or IC301 on the Mega CD2. Just apply 9-volt to the input of the 5-volt. Yeah, doing good. We're just we're trying to figure out this I'm trying to figure out this water damaged Sega CD2, and you know it's certainly non-trivial. There's something wrong with it, and we're going to have to figure it out. But it's not as straightforward as I thought it would be. So this one's quite water damaged. I don't know what's going to go on, what's going to happen with it. Um, okay, so they're saying I need to provide 9 volts. Oh, 5 volts. Interesting. When powering directly from 5 volts, nothing will visually boot, no LEDs will come on, but you should expect about 300. Okay. Do not have a Mega Drive Genesis to test the power on part of the circuit. Yeah, see, the thing is, will you get the BIOS though? Mm, yeah, so you know what would be ideal here? A ribbon. A ribbon connector. I wonder what the input. I'm trying to think here for a second. I guess the Genesis. Hmm. Like we know we have. Let me give me 1 second here. We know we have. Yeah. When powering directly on 5 volt, not when visually, but yeah. Okay. Okay, so he's done this thing, right, right, right. Um, all right, so he does that. All right, that's the Mega CD one, I guess. Um, Trace and Fable Mega Drive bad tuning power. Fuse TR3, TR4, yeah, it's the same deal. Yeah, so he's got that's not a bad idea, soldering a USB to the board so you can apply 5 volts because appear it would appear that the 5 volt line is what powers the Motorola CPU. Um, of course, without the Genesis attached, nothing's going to happen. Let me see. Do I have a? Let me see. Do I have a USB cable? Um, see. Do I have one that I'm happy to sacrifice? I don't think I really need. What's this? Oh, I do need that. What about this? Oh, I need those. There's some headphones. Okay, give me 1 second. I'm just trying to think here. Actually, give me 1 sec. Let's see. Sorry, I'm just looking to see if I have a. Let's see how it goes. There's another. That'll be useful. That's a Roku. What? I'm actually not even sure what that does. Okay, let me see. USB cable. Yeah, I guess I could sacrifice this one. Let's just have a look. Let me see. Oh, I mean, I just have a lot. I have a lot of these lightning cables, and because lightning has now become sort of useless, I guess we could just kill this cable. Might be fine. Now, this might have data lines on it too, though. I mean, it probably will. Hmm. Okay, so one of these is probably okay. So we could use a USB cable. Yeah, but yeah. So I mean, this is gonna be a waste of your time. Because I haven't made a like this. This would be a jig that I would have to build. Give me a second. Okay, let me just get the USB. Um, so the cables in this are. I guess one of these is probably. I just can't tell what color these are. I'm really bad with colors. I'm kind of colorblind. So give me a second. Maybe you guys can tell what's what, and then we can use the scope to figure it out. All right. I need to find ground. I need to find ground and power. Now, obviously, ground is probably going to be this one. Uh, what is that color? Is it red or is it pink? And then if these are probably the data lines. But so this is black. This looks pink to me. I guess this other one looks green and the other one looks white. I don't know what standards. So that's red, is it? Okay. All right. Well, then that'll be plus then. Oh, sorry. Um, Actually, you know what? Those are thicker too. Those are thicker as well, aren't they? So those are probably the power ones. All right. So let's chance that. That's probably, it's probably correct. So if you're saying that's red, I'm gonna go with what you said. And then, and then we can just go with that. Okay. All right. We'll put those over there. Now, so what would that mean? Actually, that would be fine. That would be fine. So we would be able to go, um, Yeah. Okay. Yeah, that should work. Let's just try it. Um, so what we'll do is we'll try and build a USB 5-volt power. White is data minus. Okay. Okay, cool. Yeah, I don't often make these kind of custom little cables, so this might I'm learning something here. Um, okay, I'm not sure what happened there. Oh, one side of the cable came off and the other side didn't. So that was a barrel of crap. Thank you, Klein Tools. All right, let's try it. Well, this sucks. This is maybe well, it could be my battery because maybe I've misused it. Maybe I've abused this thing. But this is a Klein Tools stripper. It should work properly. All right, so it's just not going to work for me. All right, that's fine. So much for a Klein Tool stripper. I guess I need to get a new one because I don't want to be messing around with this stuff. Um, and usually, like for things like strippers and that, I'll buy a good unit, you know. So I'm actually disappointed now that I mean, maybe this wire is too small. It probably is. But I am a little disappointed. I feel like it's not too small. Let me go see. Let me go see. All right. So that's the Klein Tools one, and this is El Cheapo Maximal. And El Cheapo works. All right, so obviously I've broken the other one then, because I don't believe a Klein Tools unit is going to just not work. I think I've probably broken this. I've probably tried to do something weird with it. Anyway, okay. All right, so here's what I'm going to do. I'm going to put the USB ground to the ground of the that's the ground of the DC, and then to the input of the fuse. That's what I'm going to do. All right, let's boot her up. Okay. And then with the let me just clip this. Yeah, so and then with that, um, then hopefully I should be able to power the board. Oh, those you mean? Oh, you mean these are just two? Yeah, they're more for electric, um, housework probably than this kind of work here right now. These are too big. Because before I kind of started getting into this stuff, I was much more into just doing stuff around the house with electrics, you know. So it's probably just it's good. All right, so that's ground. Sorry, let me just switch to scope. Now, see, this will be the ground plane, so getting something onto it will be a little tricky. All right, well, that's going nowhere. And then to the fuse. I would like a better connection there. Ah, I would like a better connection. I get a worse one. Not only do I get a worse one, but I get a more dangerous one. Oh, and also he's attached to this guy here. So none of that's good. Okay. So none of that is good. Yeah. All right, that'll do for now. That'll do for now. So obviously we're not going to get any no, let's just see. We're not going to get any things here, but we'll get 5 volts. So let's just see what happens. We'll put it on this power. Okay. Oh, 516 out. All right. Test. Oh, I see. Sorry. Yeah, okay, so hang on a sec. Mm, I'm kind of, yeah, sorry, so that's not going to work. What did he recommend again? It was different. So, what is he doing right here? Sorry. Okay, so maybe this is a bad idea because it sounds like he did that for some other reason. It looks like when you Yeah, the hack job of the diodes. Yeah, it's kind of getting there. Um, so let me think about this for a second. There are other things I can test. Let me back out. Let me back out from what I'm doing. Let me back out. Oh, oh, yeah, interesting. Why is that not heating up? Oh, it is. All right. All right. Well, okay, give me a second here. I might use that some other day. Thanks for letting me know what those pinouts were. Um, so I have another idea. Okay, so we know, let's go back to we know that in the manual, let's go where's pin one? That is just so weird. I'm just so, like, why does it say here that pin one is data line four? That's what's confusing me. Pin 14, sorry. Let me just, and then we just go back here, and then wherever we were, yeah, yeah, yeah. Oh, no, no, no. Okay, it's fine. 14 is VCC. 52 is address line 23. 53 is V ground. So what is this frickin' doing? It says 52 is VCC. 53. Yeah, you see what I mean? It's just like it doesn't line up. It just seems weird. 16, feel like I don't know, it's not lining up. Like why 56, 57, ground, right? Let me just have a quick look back here. 56, 57 data lines. Like so I don't know. It's whatever. Let's just check 14 VCC. We can always do 52 as well, just to see if 1452. Look at all the stuff that's tied into that. DTAC. What the hell's DTAC? Oh, data transfer acknowledged DTAC. Okay, pin 10. And then on the Mega Drive, DTAC is. Oh, it does look like it's pin 10. Okay. But the VCC pins is kind of what we're interested in. Goes through a filter and then pin 14. So what we can do is we can tack a probe. Um, Let me just give me 1 second. Let me just see what I have probe wise. Where did I put these? Give me 1 second. those crumbs. Give me a second here. Want to see my address probe? Logic and laser. Yeah, give me a sec with this. Yeah. All right. So just give me 1 second with these here. I want to check. So with my logic analyzer came these little. My logic analyzer came with these little clips. I just want to see if it'll actually be helpful here. So what are we looking at? We're looking at pin 14, right? So there's the M68000. There's 10, 11, 10, 11, 12, 13, 14. Oops. Oh, hang on, maybe I can't actually. Wait a second. What way is this actually? Sorry, maybe there's no legs here, is there? Oh, well, there's barely legs. There might not be anything to actually grab onto. If there's not, I'll just solder something on. Well, he's attached, isn't he? He's going nowhere. That's perfect, actually. That's perfect. And then I just need a DuPont cable. Let me see if I got one. I know I do. I got one over here. Yep, I think I have one that'll just stick onto the back of this. Yeah, there it is. All right, so now I'm on pin 14, and then I also have the other end attached to this, so now I can probe that really easily. All right, let's put that back in there. I just got that from my logic analyzer. There, the bucket. Now, again, the logic analyzer might be a whole other thing that you pull out when we want to see if the if the CPU is alive. My knockoff logic analyzer, yeah. Well, I mean, it's fine. Okay, so that's pin 14, and we can probe other pins with this little gadget. Um, and in fact, I can definitely. So there it is now, right? So we can probe other pins if we want. What other pin would be good? P clock, actually, that would be a good one, wouldn't it? P clock. Clock is it's 15. I mean, I think. Okay, let me just plug in my scope. I mean, look, I think P clock is going to be pretty useful. Um, but we'll get P clock in a sec. Let's just make sure that before we touch P clock, let's make sure that we've got other stuff working. All right, there we go. And actually, I do have probes that I could use here that are long, but if I do it that way, I feel like it will be tricky to. I think it'll be tricky to get things working too. Um, all right, just get my meter out here. I'm gonna put the meter over here. I mean, look, I'm sorry. This is a lot of setup that I'm doing that I could have like done before you all joined, but I didn't know I was going to do this. I didn't know I was going to set up all this crap. Um, so sorry about that. I mean, I didn't know I was going to have to set up any of this crap. You know, I thought it was just gonna. I thought it was just gonna work. Peatlock is lame. Why is Peatlock lame? Um, I'm just trying to see if the clock is working. Um, because maybe the oscillator is gone. All right, we'll try and we'll try we'll try both, right? So this is going to be all right. Okay, yeah. So there we go. Right, that's that. Whoa, whoops. Let's get. I mean, we don't. I mean, we don't care about video because we're not going to get video. 'Cause we've never gotten video out of this console. So I don't care about that. Um, we can plug in video though, just because you never know, right? Just because you never know. All right. So, well, we don't. We just need the meter to test. We just need the meter to test this, and then if that doesn't work, we'll put it onto 15p clock. Uh, yeah. All right. Okay. So we will probe ground here. All right. One sec. I'll show you here. Uh-oh. Sorry, you can't see it. Yeah, I don't think we have. I don't think we have power, boys. I don't think we power to the CPU. So we're gonna have to back trace that. Um, yeah, that's not good. Let me just turn it upside down. Just make. Oh, well, that's not good. All right. Did that just pop off? Um. Ah. Sorry, what are you saying? Are you saying that the CPU is gonna work? You think the CPU is gonna be good? Let me just try this again. Oh, wrong pin. Now here's the thing. Can I twist that so that it actually does it so that it's... Could I do that? No, it doesn't look like it. That's a shame. Would have been easier just to it would have been easier just to you know, solder a wire to it, to be honest, at this point. Because the what's happening is that the console is putting a little bit of pressure on the console is putting pressure on the probe. And then see if I could come in that way, it'd be perfect. Ah. You know what? I'm soldering wires. I'm soldering wires. This is just annoying. This is just annoying. It's just annoying. It's just annoying. It's just annoying. All right. Sorry, that just frustrated me because I was tired, so I just didn't have, just lost patience with waiting for that wire to show up. All right. Okay, so now we should have a. Sorry, let me just check the voltage here now. First of all, I'll just make sure that we're getting power. Is this not switched on? Okay. Okay, yeah. All right, so now put that there. All right, so now I'm testing CPU voltage. 5 volts in on pin 14. All right, let's check P clock. Okay, so P clock it says is pin 15. So we're just going to put it one over. Not the neatest, but not the worst either. Not the best and not the worst. All right. Again, it's just for quick checks. We check P clock and we'll see what that does. And if it gives us joy, we will. But we'll see. All right. So spoon tip upside down. Yeah, is that what I do now? It seems to work well. Um, yeah, it seems to work well. So I'm happy enough with. Sorry, give me a second here. Probes are. So I'm on P clock now. I'm just on the scope. I'm just on the scope. So I'm trying to just make sure that I've got enough space here. All right. So, oh, that's a pain. Okay. So let me just get some ground. Okay. And then let me just get some. All right. So let's see what happens now. So this would be just watch the scope. Uh, quick measure. Oh, my friends, that's a 12 point megahertz clock for a 12 point megahertz CPU. So we've got good clock, good CPU. Um, huh. But she ain't booting. So, but it's good. We know that voltage is getting to the CPU. We know that clock for the CPU is good. So we can, you see where it says when I press quick measure on the scope, it'll measure the clock. That's a very stable clock too. I mean, you can't. I mean, you just can't beat that. Can't beat that HP scope, man. Quick measure, 12.5 megahertz. I like it, love. Now, so no issues with clock. Now, let's switch her off. Let's try a let's try an address line or a data line. Um, let's see. I just wonder, like, is there any activity? So let me just have a quick look here. So for an address line, then you got your data lines, you got the reset. Reset's pin 20. So sometimes you would, I wonder if it's 19 and 20 test points. Oh, actually, you know what? Looking at this, right? Of course, I was soldering things on. It doesn't look like there's a test point for those, but if you look here, there is test points for some of these other things. So we could bring in the scope to test those if those TPs are on the back of the board. So let's take it off. Let's take the line off the clock for now anyway, though. Oh, that's interesting. What's going on there? See that? Is that a lifted pad? I mean, probably not. It just looks dark, doesn't it? I don't know. I didn't like the look of that, so sorry. I'll just show you what I did. I was just looking over the ICs and I saw that one of the legs was kind of a weird looking color. All right. So what I'm going to do is let me just take the let me take the wire off of the CPU, and then maybe what we'll do is we can probe some lines. So I'm just going to take that wire off, put it over there. All right. Now, let me just look at the back of the board here and see where are the test points, because there's quite a few test points called out on the schematic, but I actually don't see them here, right? So I'm wondering, are they on the back here? M59. There's a lot of test points here. So let's what we'll do is let's scope some of those test points, because I think with those test points, with some of the CPU test points, when you it'll be quite obvious when you hit uh, a data line or an address line, right? So where's the Motorola CPU again? Sorry, I gotta just. Why is that doing that? Motorola CPU is there. So the Motorola CPU is here. Let's see here if I can bring this up much higher. Probably not. Okay, so what we'll do is we can switch on the unit. Give me a head here. Give me a look here for a second. Make sure that this one something hasn't died. Yeah, all right. So we'll switch over to scope. We will have to bring in video capture, add source, droid cam. All right. So now the board is on, right? Let us have just a quick look at the schematic for a second. So on the board, we have, test point 55, 60. It's on the back of the CPU here. Let's go G2, test point M7, whatever that is. Test T1, T2, T3, T4. Oh, there was a test point for clock, it looks like. Or was there? Test point 2. Test point 2, 3, 3, 4, PL0, PL1, PL2, IPL, right, okay. So I don't know where those tests. Sorry, let me just have a quick look here on the board and see, can I see test point 1? I don't know if there are. Let me switch this off for a second. Sorry, I just want to just pull this out of its socket for a second. I wanted to see if the test points are all on this side or the other side. Sorry, I'm just looking at it here. Yeah, I see barely any. There's a couple of test points on the front of this board. I mean, I can definitely see a couple near the on the top side near the crystal oscillator, but I don't see. Yeah, I see a few test points there, but it looks like most of the test points are on the back of the board, which is good, which would mean, I'm just trying to find TP1234 now. So give me a second, let's switch back. Because you can see there, T123468. Then there's test point 55, test point 66. So there's all these, there isn't test points obviously for the data lines, but there's a lot of little test and reset though. So 66 is sorry, test point 66 is for reset. Test point 55 is for halt, right? So if we just switch back now to scope, It's not weird silent part of the stream. Sorry. Taking part in Japanese, they're insane. Calling now is not an ASIC problem, really. Maybe you think it might be a video problem? Taking parts of Japanese PS1 games, they're insane. How do you mean? What's insane about them? Like taking them apart, like trying to. Oh, you do some ROM hacking, do you? Is that what you're talking about? You're trying to do some. You're doing some ROM hacking, master. I'm trying to find these. I'm just looking for these test points while we're chatting. God, would say that these to disassemble a Japanese PS1 game. Now, I've heard that it's easier to do that now with ChatGPT because it understands assembly, but don't quote me on that. Now look at that, right? See, do you see that? Look at this. Like that just can't be right. Like you can't that can't be factory. Look at that. Let's go closer, right? Like that can't be factory. Could it? Can it be factory? All right, let's go to R101. Definitely factory. You think that's definitely factory? Because that looks terrible. Oh my God. Is R101? What like let me have a look. Let me have a look at the other side of that board. It would appear R101. I think we looked at this last night. Isn't R101 going to the LED? I mean, I can see the LED. You know what? I don't even want to look at it. It's just ridiculous. I just wonder, like, maybe the LED is not coming on, but oh God, I don't even know anymore. I really don't know. But that looks really poor. Like, that does not look like it should be like that. Oh my God. Okay, let's just find these test points and go home. 1032. My God. Okay, it's too much. Let's start looking at for these test points. Um, I'm starting to doubt if there is test points on this board now at this point. Now remember, I'm wondering, is this because it's a different board? It doesn't have the same test points or something, like who knows? Tell you what we'll do. Who cares? Let's just plug it in and let's just start probing underneath the CPU because we'll know what CPU signals look like. So let's just do that. And if we start seeing data lines and stuff like that, then we'll know we'll know that it's Monday, assembled on a Monday. Yeah, I I'm not. Yeah, I definitely wouldn't rule that out. Okay, so we don't like. I don't think these test points like just match up with anything that's on this board. Um, but these are right underneath the. These are right underneath they're right underneath the actual Motorola. So let's just probe a few of them. Let's just see if there's any activity. Like I can't imagine that. Although you know what, I did have the Super Nintendo that was resetting all the time, and it did have traffic on the CPU, even though it's just because it kept resetting. Um, so maybe we will be able to find something. All right, give me a second here. Sorry, I gotta take this apart, take this over here so I can attach a. All right, so let's. We should. You should be able to see. You should be able to see the screen. So now let's do a little probing. Uh, oh, I'm in the wrong area. Oh dear. Well, that's not going to work. Sorry. That the ground point that I picked is just not going to work. Um, all right, now we got to find. Okay, let's plug it to power again. Sorry, but the ground point I picked is not going to work. I need another ground point. Uh, hmm. Dang. Don't have a usable ground point. Um, let's see. I might be able to use it. Maybe the hack in a ground point here. No, that's not going to work. Um, oh, I might give up. Tired. Oh wait. Okay, one sec. It looks like I might be able to do something. Okay. Okay, let's just see. I don't know. I don't know if this is gonna work. It's just hard to get a ground point to here. Um, yeah. What? What category should I be in on Twitch? A bit too far left. Um, okay. Oh, okay. I thought maybe you're right. Okay, so this is sorry. Let me have a quick look here. This is oh wow, there's a lot of scope points around here, but I was scoping this M7, so let's just scope that first. Okay, so here's M7. Auto scale. Well, that looks like a digital signal. Interesting. Okay, so that's M7. Let's try G2, nothing. M59, nothing. G3, nothing. Okay, so M7 has some kind of digital signal. We could find out what M7 was, that would be useful. Now, what about all this stuff over here? G10. Nope. Okay, well that's high. What does it measure then as? Signal. Okay. M5, another signal. M10. Ooh, M10 is interesting. That's clock. Must be clock. Yeah, it's just clock. Okay, M3. Okay, also some kind of high-low signal. M9, some sort of high-low signal. M8, M2, also some sort of high-low signal, and then M1. Just quick measure that. So this board's it's far from dead, but it's just I am also far from dead, but it's also not clear to me in what state it's actually in. And the one digital signal that I'm able to pick up is from M7. Sorry. Which is a 1.25 megahertz signal at 8 volts. Okay, well I'll try move myself to science and technology. I don't know why I did that. I think what I did was I looked at the science and technology like who's looking at science and technology or something like that, and it just there wasn't anybody watching it or something, and then I just gave up or something. I think it was something like that. Okay, so let me see, let me just probe some trap, see if there's anything here, and I'm going to do one other thing before we call it a night because let me just show you something real quick. If you look here, I can actually see the edges of the I can see the edges of the chip here. So if I can actually whatever these pins are, and I can see here it is. I can't tell actually. I can't tell which pins they are, but they're the only ones I can probe. It's interesting. Like I do get like some activity on the CPU. Don't know what that is. Let me just let me tag that one. Let me tag that one and rescale it. Huh. Interesting one. Don't know what that is. It does look like the CPU might be alive though. So I think you're right, Master. I think you're right. Um, there isn't really there might not really be a ASIC problem, but it's just not clear to me then what, you know, if the CPU is running. So tell you what we'll do, right? Just for a little bit more sort of just for interest's sake, right? Let's just go over the board. Okay, so uh well, I mean, I mean, probably that's where I should pick up the followers then if I want to, get some people to watch it. Um, would be to do it in science and technology, right? Like, yeah, see, 350,000 in just chatting, right? So I was like, oh, maybe that'll be good. But science and technology, right? Let's see, like, what's in there. There's 1,000 viewers. People watching astronomy, life seismic monitor. Yeah, I mean, there's not a lot of competition in there, right? So probably people don't stream a lot to that. So maybe that's the place to do it. That's a good idea. Um let me do that next time, okay? And I'm sure people see, scopes and microscopes. Maybe they'll be interested. So thanks for that nudge. Yeah, yeah, just too many. Yeah, too many. Too much. Like I said, too much competition. All right, let's just go over the board like we always do. We've seen things before by doing this, and let's see what happens. Okay, so I'm gonna point some light at the board here. Make sure we get some nice light. Okay, so let's see, because because the CPU is running, it might actually be a case of is there something very obvious like a piece of solder or something that popped off or because underneath here, the moisture damage is kind of in a weird way, not as not as obviously horrible on the underside, you know. Um, but there could be some obvious damage here or something, you know. So we'll look through it, right? So let's go to the video section as well. So I'm going to just go down the board, down, 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 and keep going. So just go like that. Now we're into the people that gamble with not their money. What streams are those? I used to watch Twitch a lot, but I don't do it as much anymore. Okay, so here's the section we're used to. I don't think there's a resistor missing there. Sometimes there's just stuff left off the board, but that one, I think we fixed that one or replaced it. 162 looks sketchy, looks like a Monday morning job. Um, Definitely. There's a voltage reg. I mean, it definitely sketched out, but that whole R101 thing, where we had the thing, but maybe that's not an issue either. Uh, Looks like Fox saying, yeah, out SV. So power circuit. We just go to Retro 6 and see, like, does he have like a troubleshooting? Did he like when side connector boot up diagnostics? Bad bus translator, black screen, stuck a boot screen. Bad bus translator. Oh, interesting. I don't have that. There's a thing you can do here. Oh, I see what you mean. Gambling website. Okay. So you can use a 240p test suite cartridge to test the Sega Mega CD, which I didn't know you could do. So that's interesting. I was reading the Retro 6 wiki here. So that's actually an interesting one. I didn't know you could do that. And if you can do that, that might help me figure out if the BIOS is loading, it says. So I would have to get a Mega Drive 240p test suite cartridge out, buy one of those off eBay maybe. Um, okay. My God. Some Monday morning work here for sure. There's a lot of sketchy looking stuff here. There's a lot of sketchy looking stuff. Like really sketchy. Look at that thing. R130. Like that looks like very not just very not good. So yeah, there's some really sketchy stuff. There's some really sketchy stuff on this board. So let's go back over. Right, so now we're going to go through the middle of the board. That looks well sketch. It's only barely. Oh, it's only barely landed. Okay. So nothing super standing out here. I mean, like obviously it looks a little dodgy, but I don't see anything like hyper scary. There's a lot of stuff around here, a lot of solder residue. Don't know that that's it's not. I wouldn't say it's terribly worrying, but it is very visible from the top here. Like when you look at the board, you can really see a lot of residue there. I think maybe that regulator was replaced. So, okay, let's turn it upside down. Let's go the other way. Let's look at the top. Right. So it looks like so it does look like the Motorola is like working, or it's not that it's necessarily working perfectly, but it seems to be trying to do something. Um, let me just see. I want to just have a quick look and see, can we see if there's any, you know, diode issues, stuff like what we saw on the machine last night. Um, but the top of this board is quite sparse. Yeah, the top of this board doesn't have a lot of stuff on it, compared to the underneath. Diode caps. Let me kill the droid cam for now. So we got some okay diodes there. So we got a capacitor, but there. Yeah, so we might need some more diagnostic tools because we know, the standard stuff like the P clock, things like that. We'd have to then go into the Sega chips, I think, and start seeing if the Sega chips are bridged or problematic or something like that. Um, don't know exactly where the I don't know exactly where the BIOS for this thing is, but um, oh, gotcha. CD-ROM ICs are dead. Yeah, it's not even. It's just black screen, you know. It's a Sega CD black screen, and we know that the Mega Drive's working. But I guess yeah, at this point I should really just go and look for, Sega Mega CD black screen, right? And just see what does that bring up, because maybe there's just some more obvious diagnostics I should do to be able to to be able to actually get through that. Um, so yeah, so we didn't really get further tonight except to further diagnose what's going or further investigate what's going on here. I will say I still don't like the I still don't like that bridge door 101. It's so dodgy. Um, just have a look at this Sega chip. God, there's a lot of pins on that chip. If anything is even slightly off with that, you're in trouble. I'd like to be trying to resolder that one. Yeah. I guess it's possible that there's maybe a problem here. I don't see anything crazy. No, I was just thinking maybe like there might be some issue with and then there's the crystal oscillator, which we kind of, I think we validated that that's not got a problem. So I'm just trying to take it some look at some different angles just to see if anything pops out at me. But I think wow, I don't think I've soldered chips like that before. There's 68,000. There's some caps. And the water damage, kind of hypothesis here on this wasn't too bad. Like, let me just have a look at the top of that cap, actually. I will say that this particular this particular one here, this particular cap, I will say this looks absolutely rough. Um, yeah, well, we know what we can do with the CD-ROM drive once we get that going. Um, that is very unusual. Let me just have a quick look. Let me have a quick look online and just see um, what people say about Mega CD black screen. Yeah, it does. It does look pretty screwed. Yeah, it does. But it's outbound of the I mean, I think it is outbound of the voltage regulator. Let me just have a quick look at it. It's what is it? It's L40. Oh, L402. Sorry. L402. Yeah, that's like L402. Yeah, we'll find out what that is. But it's outbound of the voltage regulator, I think, and then so if the CPU is getting power, it shouldn't be an issue. Um, yeah, it just shouldn't. It shouldn't that even though it looks dodgy, it shouldn't be a problem. It's too fast for me to measure it. I think I need to get a flash card for my Mega Drive. That would be good. All right, second stage boot, bus translator. The bus translator near the CD ribbon. Well, HC245. Okay, yeah, maybe I'll try one of those. Third stage boot. Once you get to the second stage boot. Oh, excuse me. Oh my God. Okay. Oh, interesting. Oh, yeah. Well, hopefully it's not that expensive, and then I'll be just like won't worry about it. But um, get a bus translator HC245. Let me just see. Can I see that? Can I visually see? Okay, no, I can't. That's RAM. Don't know what that is. What's this? Don't know what that is. That's a CPU. Mega CD engine. Trying to see if there's HC245. I'm trying to see what this bus translator is that he's talking about on the Retro 6 wiki, but I can't find it here. Don't know what that is either. Hmm. These are definitely RAMs. Bus translator. Okay, so I don't see where the bus translator is. So I don't know what that is, and I don't know if it matters. But I'm missing a Mega Drive 2. Let me just have a quick look here. Yeah, I'm wrecked. I'm wrecked tired. Okay, let me see. What am I doing? Okay, so Sega Mega CD screen. Also, no LED. That's the other thing. So maybe that was the other thing. You were saying that the LED comes out of the. What was that coming out of? Is it coming out of the Sega CD engine? Let me have a quick look. I think last night when we were looking at it, yeah, it comes out of the Mega Engine thingamajig, right? Yeah, there it is. Comes out on pin 64, right? Of IC 101. IC 101. Okay, so the LED is not lighting up, right? Um, yeah, the ASIC, yeah. So CPU seems alive. Maybe just go. Uh, so, oh dear. Well, we're gonna need to go much bigger than that. Yeah, okay, so you seen what? Pin 64 LED red. Okay, there it is. Right. Okay. So VDD, so pin 97. Okay, so it could be then that Mega Engine, right? That Mega CD engine then is that one is gone. Maybe it just needs a recap. Yeah. Uh, well, yeah. I mean, they all. I mean, yes, they do. But Sega CD. Okay, so this particular. Oh, I don't think there's a lot of probing you can do. Let's see. Hang on. Don't think there's a lot of probing you can do while the Genesis is on this thing. And even if you do probe, I'm pretty sure it's going to short pins. Okay, so yeah, 156. How many pins are on this thing? 208. Yeah, so what, a 64? So that's looks like it's 52. Yeah, okay. So those are, so this is 53 to 104. So Yeah. So much for probe and test points, but yeah, so the LED is in around there somewhere. Now, what will be interesting there. Oh, 50 megahertz. Okay. When it's just caps. Well, you think this is just caps? These caps don't look too bad though. I mean, I know, but yeah. I mean, we could. I mean, yeah, sure. I could recap it for sure. I just like because the other ones, if you look, if I mean, if you're thinking about it, right, like all the other ones that I repaired, they don't. Some of them have their original caps, and they just, they're fine. The Mega CD2 actually does not have a huge bad cap problem, so it's just a little different in that respect. Um, so that's why I didn't like aggressively go to recap stuff like I did with say the Super Nintendos and whatnot. Um, but yeah, I mean, totally got what you said. Like, I don't know, I was just trying to see what I could learn because like recapping, I can recap and then but I do like sort of messing around and trying to see what I can find, and doing it like piece by piece. Um, Even though it obviously takes longer, but I'm not really in it for doing it per speed. I am trying to like learn some stuff. So VDD, VDD, VDD. Okay, so there's a lot of. Oh, it's pretty bad. So only, yeah, yeah. Just use it. I mean, I'm just using it just to see if signals are coming out. But I have the scope here too. Um, video. So I think what I need to do here is I need to get that EverDrive. So this one we're going to have to put it back, and we're going to have to go look at it some other time because I need to get the 240p test suite to see if the BIOS is loading. And I can tell you one thing: if it says oh BIOS isn't loading, you need a new one of these ASICs. I think that'll be it for this board. We'll just use it for parts. Um, I mean, it does look like it's water damaged and everything, but anyhow, I think we'll call it a night for now because it's just, I've been at it now for how long? 2 hours, 20 minutes. So, I think we've exhausted the avenues for this evening of there's I mean, and this one being water damaged, there's definitely more issues that could crop up with it, right? Or moisture damage or whatever the hell it is. Um, just taking a look at the back of the board, see if there's anything ridiculously obvious that I've missed. Does not appear so. Sometimes it could be just like a trace, but I didn't really, I haven't seen any rip traces either. Okay, well, you know what? Let's leave it for now, and you'll find someone else to watch now. Yeah, sorry, man. I gotta go. It's too late. It's too late. I'm tired. It's been late. I was up late last night. I went to a poker game, so yeah, it was late last night too. So I'm kind of tired. All right, guys, take it easy, everyone, and I'll see you the next time. Yeah, I know. I'm lightweight, lightweight. Okay, take it easy, guys. Yeah, well, it was just, kids' school thing. So, yeah, fundraiser. Um, all right, I'm out of here.